graphing radical functions. So today we're going to talk about two kinds of radical functions, the square root and the cube root. Now these are not the only two radical functions, but all of the other ones follow the same kind of pattern as the square root if it's an even index, and the cube root if it's an odd index. So let's talk about the square root function first. So here is the parent radical square root function, y equals square root of x. So the graph looks like a partial of a parabola starting at 0, 0 and then going towards the right. Now the reason why it starts at 0, 0 and goes to the right is its domain is only the x's greater than 0. Because if we think about the numbers we can have underneath the square root, well, we can't square root negative numbers. We get imaginary numbers if we try to do that. So when you make your table for your parent function for a square root, the first x that would be nice to use is a 0. Because if you take the square root of 0, your y value becomes a 0. Now I can take the square root of 1, that's a perfect square, so square root of 1 is 1. I don't want to use a 2 though, because there isn't a nice pretty number for the square root of 2. So the next perfect square is actually 4. And if you take the square root of 4, you get a 2. The next perfect square after 4 is 9. Square root of 9 equals 3. The next perfect square after 9 is 16. Square root of 16 is a 4, and you could keep going with this forever and ever. We don't want to use numbers in between 1 and 4 and 4 and 9 and 9 and 16 because things like square root of 2, that's not a perfect square. So therefore your y value would be a decimal, which is hard to actually plot on a graph. The next radical function we will talk about is the cube root function. So just like the square root, it does start at 0 and goes towards the right, but what's different about it is that it also goes left. So unlike square roots, with cube roots, I can actually take a cube root of a negative number and get a negative number back. So your domain for this one is all real numbers, and so is your range. I don't have to start at zeros, I can actually use negative numbers as well. But again, just like on the square root, we wanted to stick with perfect squares. So for here, we want to stick with perfect cubes. So the first negative perfect cube is actually negative 8. So to get your y value, you're going to take the cube root of x. Well, the cube root of negative 8 is a negative 2. The next perfect cube is a negative 1. So the cube root of negative 1 is negative 1. 0 is a perfect cube, so that's going to be a 0. 1 is a perfect cube. Cube root of 1 is 1. 8 is a perfect cube. Cube root of 8 is 2. And the next perfect cube is 27. The cube root of 27 is a 3. So cube roots can increase very quickly. Okay. So let's review our transformations. So we have our basic transformation layout, the same as it's been for every function so far. These don't change. The only thing that changes is how it looks inside the equation. So we have our a value. If the a value is absolute value of a is greater than 1, it's a vertical stretch by a. The absolute value is less than 1, it's a vertical compression by a. And if there's a negative a, it reflects over the y-axis. Now b is inside of our function. So b is the ones that are going to be backwards, just like c. So with b's, if you have a b value, absolute value, greater than 1, it's actually a horizontal compression, and it's by 1 over b. So it's we have to use the reciprocal to make it backwards. Then you have if b absolute value of b is less than 1, it's a horizontal stretch, again by 1 over b, use its reciprocal. And if you're a negative b, it reflects over the x-axis. Then we have our c value on the inside as well, so this is also going to be backwards. So if you have x minus c, since it's backwards, you're actually shifting right by c units. X plus c means you're shifting left by c units. And the last transformation is the d at the end. This is the one that is not inside, so it makes sense with what the signs are showing. Plus d shifts up by d units, minus d will shift down by d units. So for our first example, it says describe the transformations that took the parent radical function f of x to g of x, graph the transformed function, and state its domain and range. So we are starting with the parent function y equals square root of x, and we are transforming it to be g of x equals -2 square root of x minus 1. So first things we need to figure out is our parameters. What do we have? Do we have a, b, c, d, a combination? So the first thing I notice is that I have a -2 outside in the front. Well, that's your a value. The next thing I see is that I have this x minus 1 on the inside. That's your c. And that's the only two parameters we have this time. So let's take each one individually. So for the a value, I see that it's negative. So according to my table up top, if it's a negative a, that means it was reflected over the y-axis. So that's one transformation. Reflection over y-axis. Then I also see that the a is a 2. So since it's a 2, that means it's greater than 1. So there's also a vertical stretch by a. So the second thing is there's a vertical stretch by 2. Then the last thing I have is my x minus 1, my c value. So according to my c's, if it's minus c on the inside, that really means it goes right by c units. So as a shift right 1 unit. So that's the description of the transformation. Now let's try to graph. So when we're graphing, first we need to come up with a table for my parent function. So this is the one that you have to substitute in numbers to find the graph. Well, our parent function is a square root. So that means our x's, in order to make my x's and my y's whole numbers, I need all of my x's to be perfect squares. So the first perfect square that we can use is a 0. Because it's a square root, I can't use any negatives. So the square root of 0 is a 0. The square root of 1 is a 1. 2 is not a perfect square, so I'm going to skip x's 2. I'm also going to skip x's 3 because 3 is not a perfect square. The next perfect square is a 4. So square root of 4 equals 2. 9, square root of 9 is a 3. Next one is 16. Square root of 16 is a 4. So I'm going to stop at 16 because my graph only goes to 10 on both sides. So 16 is going to be outside my graph. So this is a good table for my parent function. Now let's talk about the transformations. According to order of operations, the first transformations we look at is the multiplication. So that means it's your a and your b parameters. So in this example, the only parameter we have is an a. We show an a of -2. So since a's are on the outside of my square root, that means a's affects the y value. So what we're going to do to all of my y's is multiply them by -2. Now your b affects your x's, but b should be right here in front of x inside, which I don't have a b parameter. So that means your x values are going to stay the same as the parent function. So let's calculate that. So my x's are going to stay the same, 0, 1, 4, 9, 16. Now my y's, multiply all the y's by -2. 0 times -2 makes 0, 1 times -2 makes -2, 2 times -2 makes -4, 3 times -2 makes -6, 4 times -2 makes -8. The last transformations that we have to talk about is the add and subtract. So this is your c and your d parameters. So for this one, we have a c value of x minus 1. Well, that means you're going to affect the x values, but you're not actually subtracting 1. Since this is inside, we have to talk about the opposite of subtraction, which is really addition. So you're taking all of your x's and adding 1 to them. Affecting y is your d parameter, which I don't have this time. So in this case, your y values are going to stay the same. So on my multiply table, I'm going to take all my x's and add 1. So 0 plus 1 makes 1, 1 plus 1 makes 2, 4 plus 1 makes 5, 9 plus 1 makes 10, 16 plus 1 makes 17. And then my y's are going to stay exactly the same as they were in my multiplication table. And there's your transformed function. So let's graph that last table and see what it looks like on the grid. So I should have 1, 0, 2, -2, 5, -4, and 10, comma, negative 6. And that's all I can fit on my graph. So your square root transformed function looks like this. And it does follow the transformations we described in the beginning. It did reflect over the x-axis. It did have a stretch because it's longer than the original. And it did shift right 1 because it should start here at 0, 0, and it does go to the right 1. Let's talk about domain and range for this new transformed function. So the domain of this, the furthest left this new graph will actually go, is here at a 1. So we have 1 less than or equal to x, and then it goes to the right forever, so that means it goes on forever in the right direction. You could also use your interval notation, 1 to infinity. That works as well. Now let's talk about range, lowest to highest. Well, my lowest graph is this actually will keep moving down, just very slowly. So negative infinity is the lowest y value, less than y, and then here is the highest y value at 0. And again, if you would like to use your interval notation, negative infinity to 0 with a bracket. Okay, example number 2. Describe the transformations that took the parent radical function f of x to g of x, graph the transformed function, and state its domain and range. So our parent function now is actually the cube root of x this time. The transformed function is the cube root of negative x plus 1 minus 4. So first we have to think of which parameters we have that are changing. So I don't see an a parameter this time because there's no number out in the front. But I do see that there's a b because my x inside is not just an x, he's a negative x. So I'm going to have to factor out that b value because I have to make it look like this with parentheses. So we're going to divide both of these by the b value. So you really have the cube root of negative 1 in the front now. Negative x divided by negative 1 is a positive x. Positive 1 divided by negative 1 is a negative 1. And then you still have minus 4 on the outside. This is the function that we're going to be transforming. Make sure it's factored out. Don't just leave the b in there. So for our transformations, I do have a b of negative 1. So since it's a negative 1, that means it's going to be reflected over the y-axis this time. Reflected over the y-axis. There is no horizontal stretch or compress because the absolute value is a 1, not greater or less than 1. I have a c because I have x minus 1 as my c value. So since it's minus 1, that means we're going to be shifted right 1. And then I also have a d parameter of a minus 4, which means I'm going to be shifted down 4. So there's the description of my transformation. So let's create our table so we can graph this new function. So the first table we're going to create is our parent function table. So now we have a cube root this time, so we need to talk about perfect cubes. So cube roots can in fact have negative numbers, so I need to include those in my parent function. Well, the highest negative perfect cube that I could fit on a grid 10 to 10 is negative 8. So y, I'm going to take the cube root of x to get my y. So the cube root of negative 8 is negative 2. The next perfect cube is negative 1. The cube root of negative 1 is negative 1. The next perfect cube is a 0. Cube root of 0 is 0. Cube root of 1 is a 1. Cube root of 8 is a 2. The next cube root is actually 27, which gives you a 3, but that's not going to be able to fit on my grid. So these are enough numbers that I need. Let's talk about the first transformation table, which is going to be your multiply table. Remember, this is your a and your b parameter. So in this case, I have a b. So since I have a b, it's going to affect my x's, not my y's. Now, we're supposed to use the reciprocal for b because I need the opposite of what is inside. But if you take the reciprocal of negative 1 and you flip it over, well, that's still negative 1. So you're going to multiply all of your x's by negative 1, and you keep your y's the same because I do not have an a value. So let's go ahead and do this transformation. multiply all of your x's by -1, and keep your y's the same. Then the next transformation we have, add and subtract. So this is going to be our c and d parameters. So our c parameter will affect our x values. So since it's a -1, I'm really doing x plus 1. And our d parameter affects our y's. So this is going to be y minus 4. So we're going to add 1 to all the x's and take 4 away from all of the y's. So let's start with the x's. 8 plus 1 makes 9, 1 plus 1 makes 2, 0 plus 1 makes 1, -1 plus 1 makes 0, -7, and -26. Now take away 4 from all of the y's. You get -6, -5, -4, -3, -2, and -1. So that's the final transformation. So let's see if our graph matches our description. So you have 9, -6. Then you have 2, -5. 9, -6, 2, -5, 1, -4. Then we have 0, -3, 7, -7, -2. And our other does not fit on our graph. So this does in fact match our original description of our function. Now let's talk about domain and range. So domain of this new transformed function, furthest left to furthest right. Well, it goes left forever and right forever, so that means your domain is all real numbers. Your range, this also goes up forever, and this moves down forever. So you will have all real numbers on the range as well. Now let's talk about how to write these equations. So number 3, let g be a vertical shrink by a factor of 1/4, followed by a translation left 4 with a reflection over the y-axis of the graph y equals cube root of x. So we have to talk about a, b, c, and d parameters here. So the first thing that happens, because you have to do these in order, is it says there's a vertical shrink by a factor of 1/4. A vertical shrink is just a vertical compression. That's all that means. It's just another word to say it. So since it's a vertical compression, that means this is really your a value. So the first transformation that we have is you're going to have an a in the front. So it's going to be y equals the a value of a 1/4 times the cube root of x. So there's the first transformation of my function. Then it says followed by a translation left 4. Well, that translation left 4, that's your c, because it's left and right. Since it's left 4 though, that really means you're going to do plus 4 in your equation. So now we have y equals 1/4 times the cube root of x plus 4, because it only affects what's underneath, not the entire function. The last transformation we have is it says a reflection over the x-axis. Well, that's also your a. Reflection over a y-axis is your a value. It says that your a needs to be negative. But when you make this negative, what you're going to have to do is you're going to have to make the negative on the outside of everything. So distribute your negative. So in this case, the negative just attaches itself to that 1/4. So your final function is -1/4 times the cube root of x plus 4. That's your final transformed function for this example. Example 4. Let g be a reflection over the x-axis, followed by a translation 3 right and up down, with a reflection over the y-axis of the graph y equals 2 square root of x minus 1. So we're not starting from the parent function this time, but we stay the same general process. The first thing that happens is we have a reflection over the x-axis. That means our b value is going to be a -1. So b is on the inside. So we're going to have y equals 2 square root of -1 parentheses x minus 1. B affects everything underneath. So let's go ahead and clean this up. So distribute out this underneath. So we have y equals 2 square root of negative x plus 1. The next thing it says that happens is a translation 3 right and 2 up. I can do both of those at the same time because one of them is a c value and one is a d value. 3 right, that's my c, but since it's right, it means it's opposite, so it's actually going to be a minus 3. And 2 up, that's your d parameter, and that's the one that's actually telling the truth, so it's going to be a plus 2 on the outside. So we've got y equals 2 square root of negative x plus 1, and then I have the minus 3 transformation underneath. Then on the outside, I will have a plus 2 transformation on the outside. So let's clean up what we can. Y equals 2 square root of 1 minus 3 makes negative 2 plus 2. The last thing that happens is it says that there is a reflection over the y-axis. So reflection over the y-axis, that is your a value of a negative 1. So a's and b's are the similar because they're going to affect everything. So when we talk about this last transformation, we're going to have a negative 1 on the outside of this whole function that we had a minute ago. So we're going to have to make sure we distribute in this negative 1. So negative 1 times 2 makes negative 2 square root negative x minus 2, and then negative 1 times a positive 2, which turns it into a minus 2. Make sure you put parentheses when you use a's and b's.